Good afternoon, everybody. Can you all hear me?
Yes, ma'am. Good afternoon.
Good afternoon. So you all must have heard I'm Dr. Kamika Chaudhary, and I'll be taking your MCS213, right?
Yes, ma'am.
Okay, so MCS213 is all about your
Yes.
yeah. It is all about your software engineering. You all must be knowing that, right?
Yes, ma'am. Yes. We are familiar with that term.
Yeah. So we will start from, as it's our very first session, so we'll start from the very beginning only. So what is this software? What is this engineering? And what is the requirement of combining these two terms together in order to form the software engineering? And why it has developed completely into a subject. We all have this subject, software engineering, right? It's not just that we have the terms and all that. Fine. So first of all, I would like to ask you, uh, how should I just talk to you all people, whether I should go in a flow when I'm teaching, or I should just lower down my speed and then you are able to understand what I'm saying? Just answer me that first of all. You
Yes,
are
ma'am.
able to understand, now? That's fine. Okay. So I'll be sharing a PDF with you all. First of all, let's just see, and then we will start. Just a second. Can you all see me now?
Yes, ma'am.
It is visible now.
It's visible. Okay. And okay. Screen is also visible now. It's not visible onto my screen. I'm just checking that. What you all can see onto your screen? What is shared?
Right
Just
now
the
it is
window, ma'am.
showing.
Nothing now? Yeah, it's nothing onto my screen also. Okay, we'll just start.
Yeah, now it is visible.
Okay, fine.
That would be fine.
Okay. So basically, this field of software engineering is related to the development of your software, right? Do we all know about the software?
Yeah. Yes, ma'am. Yes.
We all know about the softwares, right? So today the world is running onto the softwares only. You just pick up any of the field, any of the department, anything. Even if we are talking presently or we are just studying right now, it is also possible because of the softwares involved, right? So our life is revolving around the software, but it was not like this earlier, right? Just go behind like 20 years, 30 years before. The scenario was not like this. If the corona must have come 30, 40 years before, then the online education was not possible as much as it is possible today. We all agree with this? I think we all
Yes,
must
ma'am.
be agreeing.
Yes, yes.
Yes. So the everything that has been developed in this 30, 40 years of the time period is affecting our life in a positive manner, and more in the positive manner only. There are certain disadvantages of each and everything. We all must be agree with that. Right? Everything has its own pros and cons. So whatever we are dealing today is revolving around the softwares only. So in this subject, software engineering, what we are going to focus on is the entire development side of the software engineering, how this process takes place, how a software started, how from all the phases that it goes, and how it just comes out to be developed as a software. We all know about the difference between a software and a hardware. We all know about the difference between a software and the hardware, and we all also know that there is a evolution of the software and the hardware in the computer science industry. It has started from a certain place, moving from that place, and it has come to this position today, right? So in the case of the software engineering, we are going to be discussing about whether uh, just take an example of a cricket bat, right? We all know about a cricket bat. It is a product. Yes,
Yes, ma'am.
yes. So before talking about the software, let's just take the example of a cricket bat. It is a product, and most of us must have seen or used that. So just think from where this cricket bat has started until where it has reached. Now, how we are going to see that before many years, when there is a requirement of a certain kind of the product from which we can hit the ball, that basically there is the requirement of arising a need. Anything that is being produced, whatever the product you are seeing around yourself, whether you're using your phone, you're using your computer, you are sitting onto a table, you are sitting onto a chair, you are sitting anywhere, right? Everything has come out of the need. So the first important thing is the need of something, right? When there is a need, then there will be a product. If there is no need, then there will not be any product. So all the physical products that we use and that we see, that means there is a certain point of the time when the people have felt the need of that product, right? Whatever we are using, even if we are using a pen, right? We all use a pen. There has become a need of that pen. Then when the need arises, then we move towards the development of that particular product. So anything that is being developed is the outcome of the need only, right? Need is there, then we start thinking into the direction of fulfilling that need. When we fulfill that need, then we reaches to a certain product. Now we have, there are various products around us in the form of, we'll say, hardware form. To all those products, we can use them, we can see them, we can touch them, we can touch a bottle now. Yeah, that's a bottle, I can touch it, it is a product. Similarly, what I will say that there is a difference in the case of the software and any another product. Software is also being developed, but software is never being manufactured. Every another product are manufactured. They came into a hard form into our hands, then we use them. But software, we say that it is a product, but we cannot have that product into our hand, right? We cannot touch that product. It is always in the form of the, always in the soft copy form, right? So can we have any software which is there into our hand and we can just play that around like a bottle, like a pen? We do not have such kind of the softwares. That is why it is called as a software, right? So in the case of the software engineering, what we are going to discuss is how that product is being developed. Now the development of this product lies onto various phases. It goes from several stages. Then there is a final outcome that comes to us and which is called as a software. So 30 years, 40 years before, what used to happen? First of all, Software are the collections of various programs. We all know about the programs. What are the programs? Do we all know about the programs?
Yes, ma'am.
What are the
Programs are a
programs?
collection of instructions to be executed for just an output. We can say like that as well.
Yeah, absolutely. It's very, very much true that programs are basically the set of instructions and that are being developed to solve a certain kind of the problem, and they're always being written into certain languages, right? There could be any particular language in which that program is being written. Now, the collection of all these programs or the collection of a number of programs together forms a software. It's not just a single one or two or three programs. The collection of various programs is called as a software. For example, we can have a program of addition, right? Addition of two numbers. We can have a program of subtraction of two numbers. We can have a program of differentiation of numbers. We can have the program of multiplication of the numbers. When, for example, we have a mathematical software, when all the programs of mathematics means when all the programs that solves the problem of mathematics comes together, then we say that it is a software of mathematics. So now we understand what are the programs and what are the software. So programs are basically the individual units used to solve a smaller problem, right? And software is what? Software is a collection of various programs that solve a particular, for example, a domain of the problems, a subject of the problem. Mathematics is itself a subject, it's itself a particular domain. So when all the programs that are solving the problem of mathematics comes together, and what they form a software of maths. We can give any name to that software. So what we say that it forms the software of mathematics. So that is called as the software. Now we are going to see a number of things. We are just going to just go a little behind in the history, and we'll see that what happens in the previous decade or in the last few decades. There were a processor, there were a technology, right? Then the memory technology was there, the integration of devices were there, and the processor technology was also there, right? We have all these hardwares, but what started happening is that there is a certain kind of the change that comes on happening. So when the changes in the hardware is happening, what is the requirement? The requirement of the software compatibility with that hardware also arises, because the software and the hardware, when comes together, when they works together, then only a total system or the total computer system works. If the softwares and the hardwares are not compatible with each other, then the computer system or a particular system will not be able to work properly, right? So there is a requirement to maintain the compatibility of the software with the hardware, because the complexity of the software has changed much in the recent past. In the 1970s, what used to happen? The programs were very small, they were very simple, and it was very easy to execute those programs. But the development of the software for such system used to be very easy because the program is simple. Example, the program of addition. So when we just need to add 2 number, 3 number, 4 number, 5 number, we just need to develop a software system which is going to be very simple, and it is also going to be very small, and it is also going to be easy to execute. So that used to happen in the 1970s. But when the time changes, the development of the software also changes, because what we have right now we have very high speed multiprocessor systems which are available. Then when the multiprocessor systems are of very high speed, then the softwares that are required to be developed for the whole of the organizations are also going to be complex as compared to the previous softwares, right? Earlier the softwares were very simple, of like for a subject only. Now For example, we have a software of mathematics. Now we have the softwares which needs to be developed for the entire organization. Now we have the proper software companies, which was not there earlier in the time. What used to happen earlier in the time, that we have an industry which manufactures car. Now in the car manufacturing industry, we will just have a software that is going to maintain and manage our inventory section. So in the entire industry, we have just one software that is maintaining and managing our inventory part. So earlier the thing was like that, the softwares were there, but they were not for the entire organization. The time was not like that ki the entire world is working on to the softwares only. It wasn't like that. It was, but software exists, they were into their earlier phase. So as they exist, their requirement was less, that is why they were less developed. But with the time, the requirement kept on increasing, so the complexity of the software also kept on increasing, right? So now what is felt is that there is a need for the development, or there is a need for the engineering techniques in for the development of the software, because as the software are developing, they are becoming complex, they are becoming very huge in size, and they are becoming, their complexity is increasing. So there is a requirement of the particular process which needs to be followed for their development. Earlier, the people used to take a very less amount of the time in order to develop any software, because it was of it was very small kind of the software. But when the requirement increases and we do not have any particular process to follow, then what we used to feel, that the software development is a very cumbersome and a very chaotic process, right? Because the requirement is coming at any point of the time from the client, and the requirement is also changing. For a particular day, the client is saying that I just want 1 2 3, these three types of the functionality from my software. But as the time passes, the developer is working on to those 1 2 3 functionalities for the software. The client came again and he said that now I don't want the functionality number 2, I want the functionality number 3 and the functionality number 4. So what is felt that key, when the software has become very complex, it has become very difficult for the software developer to develop the software without following any particular set of steps. So that is basically that basically arises the need for the development of the software engineering. So what I told you till now I have told you that earlier the software were very simple, they were very easy to use, they were very easy to develop, there were not much requirement from the client side. So and the hardware technology was also not much developed, therefore it was very easy to develop the softwares. But in the current scenario, the software development has changed, the multiprocessors have changed, there are many things that have happened in the hardware field also. Therefore the development of the software has become difficult, because the requirement is kept on increasing. Therefore there arises a need of certain set of steps, certain set of processes which needs to be present for the development of any software. So I've told you till now the requirement of software engineering. So when there arises a requirement of the certain processes in order to be followed, what is that process? That process is, just imagine you wanted to develop a software. Now you have certain set of rules and regulations, steps which are present in front of you. You have to follow all these rules and regulations and steps, then only you will be able to develop a software efficiently or more efficiently, right? So that proper process, that set of steps, that systematic thing which needs to be followed is comprised in the engineering thing. So I'll just read that what software engineering is termed in terms of IEEE. what it says that the application of a systematic, disciplined, and the quantifiable approach for the development, operation, and maintenance of a software is the software engineering. So what we need to learn from that, we need to learn that engineering applications which are systematic, disciplined, quantifiable in their nature, they are required in order to develop, operate, and maintain the software. That is why we have come to this subject, which is called as the software engineering, because when the software was not so developed at that time, also there are various branches of the engineering. For example, we have civil engineering, we have mechanical engineering, we have electronic engineering. So all those branches were flourishing because we have a product that is coming out of those engineering branches, right? So they have the certain set of process which they used to follow. So that process is being adopted by the software industry also. Why they have adopted that particular process? They have adopted that particular process in order to develop, in order to operate, and in order to maintain a good quality software, right? The overall aim of the software development is what? The software should be of good quality, it should be error free or the bug free, there should be a maintenance phase of the software, right? So these are all the things that are there into the software. I just hope you all must have understood the need of the software engineering. Do you all have understood, or I should explain it further? Can I expect an answer?
No, ma'am, it's okay. That's
Yeah.
clear.
It's clear, sir.
Okay,
It's clear.
it's clear now. So from there the need have arises. Now what we have, now we also need to understand the difference between the programming and the software engineering, right? Programming is basically the overall coding part of any software, right? Software engineering is not just about the coding. Software coding is a part of the development of the software. It is not like that. What we generally think when we say that, when we just meet to any person, he says that I am a software developer. What we just think that he just do the coding in a certain or in a particular language, right? That is the general notion about the people, but it's not like that. There is a difference between the programming and there is a difference between the software development. Programming is a part of software development. Programming means just understand, programming is the coding part. Coding is one of the part of the software development. It cannot be considered as the complete software development. The complete software development at least have 7 to 8 phases. We will just study about all those phases, right? How many phases? At least 7 to 8 phases are there through which a software goes through, and then we call it as a product, right? Otherwise, and what happens in the case of the programming, it's just the certain codes which you write. So we'll just understand that programming is a part of the software engineering. We will not misunderstood that if somebody is saying that I am a software developer, that he is just focusing, or what he is just doing is about the coding part of the software. No, not at all. What else the software engineering includes? It includes the activities like the cost estimation. Cost estimation means how much will be the cost of that particular software that has been developed. Now, the time estimation. Time estimation means estimating how much amount of the time will be required to develop that particular software. Then the designing phase of that software, and then just read this coding part, right? If we consider all these things, coding just comes as a single point, which cannot be considered wholly as the software development. No, not at all, right? It's just a part. Then what else software engineering includes? It includes the documentation parts, it includes the maintenance part, the quality assurance part, the testing of the software part, and many more parts like that. So, and it is also being written that whereas programming includes only the coding part. So all these terms that we are seeing over here are those important terms with whom we all are going to deal in this subject. Just remember, just see all these terms: cost estimation, time estimation, designing, coding, documentation, maintenance, quality assurance, testing. Everything we are going to discuss, and we are going to see all those important points in so much of details, right? If you wanted to set an analogy, you can set an analogy like, for example, I gave you the example of a cricket bat. Cricket bat, before the development of the cricket bat, there will be a cost estimation that what will be the overall cost of this cricket bat, how much time is going to be taken in order to develop that cricket bat, what will be the design of that cricket bat, what will be the functionality of that cricket bat, and what will be the documentation part. Documentation part means when we are going to purchase that bat, there comes a manual with that ki how to use that bat, how to take care of that bat, what is the process by which that bat has been developed, what kind of the wood is being used in that bed. So that manual is the documentation part. After that, the maintenance part of the bat, cricket bat, then the quality of that cricket bat. Then before delivering that cricket bat to you, that has undergone through the various testing phases. So this is the kind of the analogy that is being set between any of the physical product and our software product, which is not available to us into the physical form. We all will be agree with that. But the process that we are going to follow in the development of this software is the same that we follow in the development of any of the product, any of the hardware product. We all must be agreeing with this. We all must have seen about that. Even if we just think about setting up of our own business, just for example, we wanted to manufacture any product. We wanted to manufacture a pen from our own brand. All these are the factors that needs to be considered before just dive into that particular business, right? So all these things we are going to see into the software engineering. So we are also going to read that. And along with all these features, there are also a set of another features like the reliability of the software, the future expansion of the software, the reuse of the software, and etc. So all these are the important things which differentiate between the programming and the software engineering. Now we are going to go to this part. Is this part just going to discuss about the evolution of the software engineering, that from where we have started and from where till where we have reached. So in spite of reading this entire paragraph, what I have done is that it has gone from here. Okay, so we are just going to see this table, and in this table everything is being summarized for you already, right? So 1960s, we have named this time period as the infancy period. Then in 1970s, we say that this is the project years. From this time period, we have called the software development as the project years. Then 1980s is the another kind of the project years, which has this feature. Then 1990s is the process and the production era. And after the 1990s, we are now into the reusability era. So we are going to see what happens in the case of the 1960s when the software development was in its infancy stage. So what was there in the infancy stage? We will just see that in the earlier years, the software size was very, very small. So it was developed either by a single person or by a very small programming team, right? Just imagine in this 1960s, we were developing the software for solving a addition problem of mathematics, right? So if we just need to develop a software for the addition problem of the mathematics, what we require either a single person is going to develop that particular software, or we'll just require a very small team of the people, either 2 or 3 people. They're just going to come together and they're going to work onto that particular software development, right? So that is why what we say that the 1960s time period was infancy period. What is the meaning of the word infancy? The meaning of the word infancy is the child. When when any of the product is in its very initial stage, is in its very initial phase, that is called as your infancy period, right? So in the 1960s, team was small, the software was very small, it was very simple. That is why it is called as the infancy stage of the software development. Then in the 1970s, what started happening? It is written that the size of the software of the application, the size of the software and the application domain of the software increased as compared to the infancy stage, right? Now there is a requirement of the bigger team as compared to the previous infancy wali team, right? Now we need a bigger team, we need more number of the people which needs to be engaged in the development of the software. And in this period, certain high level programming language has also entered. Now we are not into the machine language only, higher order programming language, for example the Pascal and the COBOL were introduced till this time period, right? Then after that we come to the another project years, which is called as our project development stage. So in this time period, now the entire organization needs to be into the software. Now it's not like that ki we just need a software for solving a mathematical problem or solving just for the mathematics. Now we need the software for the working of the overall organization. That is why we just have the proper companies now, which are called as the software companies. Before the 1980s and 1990s, there were nothing like software companies. Now you just imagine about the Silicon City, now which has a number of the software companies, right? So from where these software companies started, these software companies have started from the 1980s and 1990s wala era, right? What, you people are joining and not joining again? Okay, so in the 1980s and 1990s, now we have the full-fledged organizations which are called as the software houses for their development. So when the software requirement has increased so much that it has been needed by the entire organization, now we need much and more number of the people for the development of these software. Now we have various teams which are called as the project teams for the development of the software. Now what also has happened that various tools have also been developed so that the software development has become easier. The tools like the case tools. The case tools is what? They are the computer aided software engineering tools. What is the function of these tools? They just help in the development of the software and they make the process faster so that not a lot amount of the time is being given for the development. Now we have developed a particular tool which is going to help us for the development of these softwares, right? I can also give an example about that. For example, there are certain set of instructions, certain set of libraries which are required in each and every software. So what we do, we just make them, and we make them with the help of these case tools, and developing them with the help of the case tool is what? The development of all those libraries are very faster, right? Now, when the case tool has developed a library once, to develop that library again onto that tool is become very easier, and it also takes less amount of the time. So this happens in the 1980s and 1990s. Now the industries have come into existence, and those are the software industries. Now from 1990s to now onwards, now we are till 1990s, we have reached on to the all the learnings, how we need to develop the software, how we need to manufacture, how we need to just come to our product, right? Now we know everything. We know the various programming languages are there, various tools are there which are helping us. Everything is there. Now, after the 1990s period, the time comes when we have come to the very important aspect of reusability. Reusability means we have a particular product and we have the process to use that product again and again, right? So we know that the mathematics and the computer science are the two very related domains, right? The computer science people needs to know the mathematics, everything is there, right? So for example, I am developing a certain software for what, for solving the, for example, arithmetic, for example, I'm developing a software of the artificial intelligence, right? So when I'm developing a software for solving any problem and I'm developing the software for artificial intelligence, now what should I know? I should know the mathematical part also, because in order to develop any artificial intelligence software, there is a requirement of knowing the various theorems and the various properties and the various things from the mathematics also. Now I'll see that if I have certain set of the softwares which are already being developed, which are related to mathematics, now I am in need of all those programs, I am in need of all those softwares. So what I can do, I can take those programs and use into my own AI, yeah, artificial intelligence software, used in my own development of the AI software. So that is called as the reusability. Now, just suppose I have developed a robot or I have developed a software which is my AI software. Now I'm working on to the another software, right? Now what I see that the previous work which I have done into my software number one, it has got a certain part that can be used or that is similar to the software on which I am working right now. There is a particular part which can be taken from my previous software. So now what, in which era we are in? We are in the era of reusability, that we can use a particular set of code again and again. We can use a particular set of the software again and again, how much time we are in requirement of. There is no foundation of reusing any part of the software. I hope you must have understood that. You must have understood this evolution from where we have started. We have started from a team or from a single person which has developed a particular software, to now we have the entire companies which are called as the software companies, and presently into the era of the reusability. Why? Because the software creates the most valuable product of the present era, and which is what? Information. You all must have heard about that information is the new gold. If you have the information in the today's era, you have everything, right? That is why we have this saying also that information is the new gold of this time, and softwares creates this most valuable product which is called as the information, and it has also included itself the very important aspect of reusability. So this is how the software engineering has evolved from a single person team to a complete, what, companies are there, right? Software houses are there. So we have learned about this. Now we are going to just remove some of our misunderstandings about the software. What? We'll just read from here that the problem arising in the development of the software is termed as crisis. Obviously, the software development is not a very easy process. That we have been told by our client that he needs a certain kind of the software. We'll just start it and it is going to be done. No, it's not like that. It's not at all like that. It is a very, very lengthy process, very cumbersome process, and its development, and there are certain set of the problems that arises in its development, and those set of the problems are called as the crisis. Now the process of the development of the software rather than software functioning, a software crisis, how we are going to define it? We are going to say that the software crisis includes the problem arising in the process of the development of the software rather than the software functioning. Now, what are the common misunderstandings regarding the software development? The common misunderstandings are: the correcting error is easy. What the common people think? The common people think that it is very easy to remove any error from the software. No, it's not like that. Removing the error from any large software is a very difficult task. It is also written into your book also. What? It says that though the changes in the software are possible, but making the changes in the large software is extremely difficult task. You must be understanding this from this word. Extremely difficult. It's not written like that. It is actually very difficult to correct any error from the software, because just imagine when a single program can be of thousands of lines. Software is a collection of thousands of program, and to find out and to locate any particular error in those thousands and lakhs and millions of lines of codes, it's very difficult task. So this is a misunderstanding that correcting the error in any of the software is very easy. It's not like that, not at all. Fine. Now the second misunderstanding is that by proper development of the software, it can function perfectly at first time. Now this word perfectly is also very important. No, it is never like that. Theoretically it is possible, but we can never say any software to be perfect. Never ever. The softwares which we are using is also never perfect. We all have heard about the viruses. We all have heard about the viruses, right?
Yes,
Yes,
ma'am.
ma'am. Yes,
Yes.
yes.
So if the software is perfect, then there shouldn't be any virus that should affect our software, right? So what it says that no software is perfect. If the software is of perfect nature, it itself is of perfect, it is itself is of perfect, then what? Then there shouldn't be any virus that could hamper our software. Viruses are everywhere. So that it itself says that no software is perfect, right? So that is also a misunderstanding. What kind of the misconception we have into us, that if we are working onto a computer system, if we are working onto a particular software, if we are using onto that particular software, that is the perfect software. Now nothing is going to happen. No, viruses exist. So what it proves? It proves that no software is perfect in nature. What is the third misunderstanding about the software? The third misunderstanding is that the loose objective definition can be used as a starting point. Once a software is developed using the loose objective, changing it for specific objective may require the complete change. What is this loose objective and what is this specific objective? Right? Software, there is a software client. We all understand the word client. Client means somebody who is in requirement of the software. For example, I am a client. I want a company to develop a software for me that is related to the particular education software, right? I wanted to develop my own software. I'll just go to a particular company. I'll ask that company that this is my objective. I want a education related software. I'll just say this much, right? So what is this? First of all, if I'm going to somebody and asking for a product, then I am a client, right? I'm going to that company and I'm just saying that I want a product which is related to education. I want a software related to education. Now, what those people would understand, education software could be of many types, right? It could be a software for studying, it could be a software for evaluation, it can be a software for examination, it could be a software for admission, it could be a software for the employees, it could be a software for the students. But if I'll just say to the company that I want a software that is related to education, so this type of the objective that I'm giving to that particular company is the loose objective, and loose objectives are always very destructive in nature, because if I will not be clear what I need, what those people will be understanding who will be delivering the product to me, they will not be understanding anything. They will just deliver whatever they wanted, right? Whatever they will just understand by just this simple sentence that I want education related software. They are just going to use their own brains, they are going to do their own brainstorming, and they're going to come up with the product which could be after the development of the product, I could feel that no, I just do not want all these things into my software, right? But this is going to happen because I haven't explained them clearly. If I would have explained them clearly, then only I'll be getting a product which I am needed. But if I, as a client, myself is not clear, then I should not expect the any kind of the software which is going to fulfill my need, because I haven't delivered my need to the developer, right? So the loose objectives cannot define can loose objective definitions cannot be used as the starting point. Never ever go with the loose objective. If you want something into your mind, if you have all the things into your mind, just go to the company and explain them that these are all the things which I need into my software, right? Then the third misunderstanding could be more manpower can be added to speed up the development. Software is developed by well coordinated teams. Any person joining it at a later stage may require the extra effort to understand the code, right? Just take a very simple example. For example, any one of you or all of you have written a code, right? I have given you a code to write. I have given you a program. Just write a code about the Fibonacci series or write the code about the prime numbers, right? Then you all will be writing your own codes. It is possible that the code of a one person is of 5 lines. It could also be possible that the another person could have solved the same problem into the 500 lines, right? So if I'll just say the person number one to go and read the code of the person number two, it is going to be very difficult for the person number one to understand the code of the person number two, because that person is going to join person number two when he has finished doing that work, right? And to understand anyone else's work, especially in the coding form, is very difficult. So it is also misconception that if we will add the more number of the people in a particular team, then our software development is going to be the process of the software development is going to be speed up. No, not at all. It's just the very well coordinated teams which are required in the development of a particular software. So these are all the 4 misconceptions which are there. Now after this, we have the certain software development models. What these models are? Models means there are various models which are being developed. 4 types of models are there, 4 or 5 types of models. Now it is on to the particular set of the company which model it wanted to use for the development of its software. Means now understood that there are 8 to 10 steps which are there in the development cycle of any software product. At least 8 to 10 steps are needed to be followed, right? But all these 8 to 10 steps cannot be applied onto the development of each and every software. So we have developed a certain set of the models. Now it depends on to the software company which kind of the model it is going to follow for its software development, right? We are going to study about all these models now. What it is saying over here, okay, we are just seeing the difference between any of the engineering product and the software. I think in spite of studying it, we are just going to, we can take this, we can see this. What is the importance of the software engineering? These are all the theoretical things which could be understood very easily. You all must be having this book, right? You can download this book from your IGNU website. You all must be having this book.
Yes.
Right?
Yes,
So
we do
these
have.
are very theoretical points which are written over here. If you want me to make you understand or read all these points, I can do that. Otherwise, they are not of very much significance. We can move on to this point of importance of software engineering. What you all say? You all will be able to read them, or I should read them for you all people?
We can read them. We can read them.
It's
And
okay,
just
ma'am.
Yeah, you can all read that. Okay, very good. Okay, we'll just see what is the importance of this subject of ours, which is called as the software engineering. Why it has become so important? Because it answers to various queries of any client. What are the queries of the client? That what is the best approach to design of the software? why the cost of the software is so high? Why can't we find all the errors? And why is there always some gap between the claimed performance and the actual performance, right? देखो बच्चे, we need to understand this. Software, first line is software is never perfect, right? No software is perfect till today. Why? Because you just pay any amount of the hard work, any amount of the expertise in the development of the software, but still there will be certain set of the errors which are going to be present, right? So software engineering helps us to see all these points together. What is the point number one? The point number one is, what is the best approach to design of software? If we are going to make use of the software engineering, the company is going to see that from various approaches, which is the best approach for the development of my software. This answer is going to be provided by the software engineering only. Second is, why the cost of the software is so high? Obviously, the client is going to ask now, when the company is going to ask the client to pay this much of amount, then the client is going to ask why the cost is so high, why I should pay so much of money. Then the software engineering has the answer of this question too, ki why the cost is so high. Then the client is also going to ask that why can't we find all the errors? Because if your company, your team has developed this software, but still why we cannot find all the errors, still why there is a probability of existence of error in the coming future, why you all can find all those errors presently and fix them all. This answer is also going to be given by the software engineering only. Then the next question is, why is always there some gap between the claimed performance and the actual performance? Now, the software company which is going to develop the software is going to claim certain index about the performance of that particular software, that it is going to give the 90% efficiency, it is going to perform 75% efficiency, but the actual performance of the software is always going to be lesser than the claimed performance, right? Software companies, software teams, software development teams give their best so that the claimed performance matches with the actual performance, but it never happens because of the certain set of errors that can arise at any point of the time. So the company is never able to provide the actual, is never able to match the claimed performance with the actual performance, right? So to answer all such queries, software development has adopted a systematic approach. Now this model wala partner, this software development models, they are the systematic approach which are going to solve all these problems, not solve, which are going to give the answer of all these problems. They cannot be solved, only they will be answered, right? So now we are going to see the various development models which are present. First is our build and fix model, right? The name of the first model is your build and fix model. What it says that it is a simple two-phase model. In one phase, the code is developed, and in another phase, the code is fixed. This is the simplest kind of the model, right? What it is doing, what the company is doing, it is developing a code, right? And then it is providing that code to the client. Fine, client is using that product. Now client is finding certain problem into that product. The company is going to come, it is going to fix the problem and go away. Then give the product to the client, right? Now if the client is again going to use the product, then after a month, he is finding another set of the problem into the software. He is again going to call to the company. Company people is going to come again. He's going to fix the problem. And again, he's going to leave the product with the user and just leave. So that is the build and fix model. Means whenever the problem is occurring, it is being fixed then and there. It is not like that ki the software is going through various stages of testing. No, it's not like that. The testing is being done by the client only. The testing is being done by the user only. So that is the build and fix model. I hope you all must have understand. It is the very simple model, the simplest of all. Develop a product, hand over that product to the client. Client is going to use the product. Then client is going to feel any kind of the problem into the product. Client is going to call the company. The company people is going to come fix the error, and then again the client is going to use the product, and the cycle keeps on repeating. Right? That happens in the case of building fixed model. What it says, it is written over here also, that develop the code, fix the code until the client is satisfied, and deliver the product. Bas, itna sa. It is very, very small kind of the model. It includes only 2 steps. Develop the code, fix the code until the client is satisfied. Client keeps on calling you, keeps on coming, you keeps on just fixing the errors, and then finally you deliver the product and left. That is the build and fix model. You all have understood?
Ma'am, excuse me.
Yeah.
I want to just ask a question. This, if it is actually of use or how? I think it is practically it cannot be used, I think.
It used to be used in the previous time when the softwares were very small size now. Then at that time it was like in the starting phase. Then it was like that you just develop the code, you just fix the code until the client is satisfied, and ultimately when the client is satisfied, then you are like done, you have delivered. But presently it is like very rarest of rare chances that this model is being used. But we are going to study all the models that exist. Right? This was also a kind of the model which used to be exist and which is being followed by the people in the earlier times. Understood?
Okay, ma'am.
Okay, it cannot be used right now. Now, the next type of the model is your waterfall model, right? Now that this is the way kind of the model which could be said as the standardized model, and it is the simplest and the oldest, and it is also written over here that it is the most widely used model which is being there for the development of any software product, right? So waterfall model means whenever in your future also now, if anybody is going to talk to you about the software engineering, one thing he or she is going to ask you about the waterfall model. It is so damn important. Just understand it very clearly that it is simplest method, it is the oldest method, and it is one of the most popular model that is being adopted by the people for the development of the software. So what happens in this model, it has got the various phases, and each phase of the life cycle is completed before the start of the new phase. Now this is very, very important line of this waterfall model. What happens, these are all the phases which are written over here. So after going through all these phases, then we'll say that our software is being now ready and it is being delivered, and now it is into the last phase, which is the maintenance phase, and maintenance phase is always the ongoing phase, right? So what are all the phases of the waterfall model? We have got the requirement analysis, we have got the design phase, we have got the coding phase, we have got the testing phase, and we have got the maintenance phase. Right now I am saying all of them as the phases. In the coming classes, we are going to read them as the chapters and the units. Requirement analysis is itself a unit. Designing is itself a unit. Coding is itself a unit. Testing is itself a unit. And the maintenance is itself a unit. So just understand the significance of this model, that how much significant it is. That the overall software engineering revolves around all these important steps. Just so you have to focus, you have to understand very well. This model is of the great significance, right? You must know about the requirement analysis, you must know about the designing and coding and testing and the maintenance only, right? So what happens in this case, in the case of the waterfall model, until and unless my requirement analysis phase is not completed, I cannot move on to the design phase. That is why it is called as the waterfall. You can see the arrows falling like a water. And the most important asterisk point is in this is that once the requirement analysis is completed, then I will go into my design phase. Once the designing of my software is completed, then I will move on to the coding phase. Once the coding of my software is completed, then I will go to the testing phase, and so on. if my designing phase is not completed, I cannot go to the coding or the testing or the maintenance. Just forget about that. I cannot even go to the coding phase. So that is the most important feature of this model, which says that each phase of the life cycle is completed for the start of the new phase, right? So it is actually the first engineering approach of the software development, which is also being followed, or which is also being considered as the standard of the software development, right? From this model only we move on to the another different models. What is this model says? The waterfall model provides a systematic and the sequential approach to the software development and is better than the build and fix approach. Obviously, we understood that build and fix approach is like a continuous approach. You just develop it, you just fix it. You just develop it, you just fix it. You never know till when this process is going to be repeated. So the waterfall model is always considered to be way better than the build and fix approach. Now, what happens in this model? The complete requirements should be available at the time of the commencement of the project, but in actual practice, the requirement keep on originating during the different phases. The waterfall model can accommodate the new requirements only in the maintenance phase. So this is the disadvantage. So what another thing we all must understand that these two important lines, these are the very important lines that is why I have just underlined them. What happens whenever we want any software to be developed as a client, I'll just give a particular set of the requirements to my developer team, right? To my software development team. But what actually happens in the starting, what I will feel that I'll feel that ki, I know all my requirements. All these are the set of the things, or all these are the set of the functionalities which I want my software to do. But what in reality happens is that the requirements, they always kept on originating during the different phases, but they cannot be applied during the different phase. For example, just see this requirement analysis phase, right? I am a client, I have given my requirement to the developer, and he has entered into this requirement analysis phase. Fine, he has done the analysis of all the requirements, what is being required by me, how my software should be working at the end. Now, after understanding or after taking all the requirements from me, he has moved on to the design phase. Now, after the designing phase, he has moved on to the coding phase. But at the time when my developer was into the coding phase, what I feel as a client is that I have more requirements for my software. There are another needs which has arisen and which I want my software to work, right? But now the developer is into the coding phase. Now it cannot happen that he can move back to the requirement phase again. No. What will happen? He will be into the coding phase. Obviously, he's going to take the requirement from me. He's going to just save them to work on. But presently, if he's working onto the coding phase, he'll just going to work onto this phase. He's going to come to the testing phase. Now he will complete the testing phase also. After that, he is going to come to the maintenance phase, and when he will reach to this phase, then only he is going to see what were my new requirements. Before reaching to the maintenance phase, he cannot work on to my new requirements, right? If he is into the maintenance phase, now he can put the attention on to my new requirements. So that is considered as one of the cons of the waterfall model, that if the requirement has changed during any of the phase of the cycle, then that requirement cannot be applied to that particular time until and unless the developer reaches to the maintenance phase of the waterfall model. Understood?
Yes, ma'am.
Yes, ma'am.
Okay. Now, we also have another slight variant of this waterfall model, which is called as the waterfall model with the feedback, right? How it looks like this. We have all the phases similar to the waterfall model. We have the requirement analysis phase, we have the design phase, we have the coding phase, we have the testing phase, and we also have the maintenance phase, right? So the slight modification of the waterfall model is a model with the feedback. Means once the software is developed and is operational, then the feedback to the various phases may be given. It is the software is developed, it is being handed over, it is into the maintenance phase. After that, the feedback can be given back to the developer about all the various phases. Now the developer can also work on to the all these phases, and he can take the feedback from the customer, that how he feels about the, obviously we all know about the feedback now. Even if we go to a for example, we go to a particular set of the restaurant, we just had the food, then the restaurant people also make us to give the feedback that whether we have enjoyed the services of that restaurant or that hotel or not, right? So this also happens in the case of this waterfall model with the feedback. Don't confuse with the simple waterfall model and the waterfall model with the feedback. The additional thing in the feedback model is that now it also gives the feedback about the various phases of the waterfall model. Otherwise, everything else is same. All the phases are same. The requirement analysis, design, coding, testing, maintenance. So this was the second type of the model. The first type of model was the build and fix model. And just a second. Next is our waterfall model. And then after that, we are going to come to our iterative enhanced model, the third type of model, right? So the developer team is going to have a number of choices. Now, choices are there, which type of the model the developer team or the software development company wants to make use of. It just depends on to what type of the requirements are there. Now, iterative enhancement model means the development of the software is happening into various iterations. Like in this model, the phases of the software development remains the same, but the construction and the delivery is done in the iterative mode. In the first iteration, a less capable product is developed and delivered for use. This product satisfies only a subset of the requirement. In the next iteration, a product with incremental features is developed. Every iteration consists of all the phases of the waterfall model, which is very, very important to understand, right? Now, what we do that, first of all, what we have felt that when we were using the waterfall model, then, and what we were trying to develop the complete software, and then we will deliver to the client, right? During this entire process, what the company felt that it is taking a lot of time, right? And then when the product is being delivered to the client, the error part that comes on happening is also another time consuming process. So another kind of the model comes into existence, that is called as the iterative enhancement model. Now understand it like this. For example, there are 10 set of requirements, 5 and 5, 10. These 10 set of requirements that are being asked by the client to develop. That I want objective number 1, objective number 2, 3, 4, 5, 6, 7, 8, 9, 10. All these objectives needs to be fulfilled by my software or by the software that this company is going to develop. I just have all these 10 requirements, right? So what the company is going to do, the company is going to divide all these 10 requirements into 5 phases. 5 phases means 5 iterations. That in my first iteration, I'll just deliver the objective number 1 and objective number 2. Or objective means need of the client. Need number 1 and need number 2 is going to be fulfilled in my first iteration. Need number 3 and need number 4 is going to be fulfilled in my second iteration, right? Need number 5 and 6 in my third iteration. 7 and 8 in my fourth iteration. And the need number 9 and 10 in my fifth iteration. So now the company has divided all these 10 objectives into 5 iterations. But when the company is developing a software that is going to fulfill the need number one and need number two, it has to undergo through all the phases of this waterfall model. For need number one and need number two also, it has to go through the requirement analysis, it has to go through the design part, it has to go through the coding phase, testing phase, and the maintenance phase. Now, after following all these phases of the waterfall model, the need number one and need number two are being fulfilled. Now, this product is being given to the client. Ki all these two important needs of you are being fulfilled. Now, you can make me the payment of these two important needs that I have of yours that I have fulfilled. Make me the payment. If you find any set of the problem in these two needs, then till the time I'm working on to your need number three and need number four, you can tell me, right? It is not like that you have to just wait, you have to sit and wait for the entire amount of the time till I fulfill all these 10 needs of yours, right? So it is kind of the time saving model, time saving in all the senses, time saving also, and the financially it could be a better model as compared to the waterfall model. Obviously all the steps is followed in each and every model. These are the standard set of the standard set of steps, right? So what happens in the case of iterative model, you have these particular objectives, you divide these objectives into the iteration, and according to the iterations you are delivering your product. 1 2 fulfilled, you use this product. Now 3 4 fulfilled, now you use the 1 2 3 4 objectives fulfilled product. Now 5 6 fulfilled, now you use the product that fulfill all your needs from 1 2 3 4 5 6, and till you are using your product which is fulfilling all your 6 needs, I'm working on to the another part of the product which has your 7 8 9 and 10 needs. So that happens in the case of the iterative enhancement model. And during the time I'm working on to your need number 7 8 9 10, you just tell me after using your product that these are all the problems which you are facing, so that in the meantime I can solve your problems, I can solve the problems which you are facing into your product. Fine, understood?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Now the next type of the model. The next type of the model is your prototyping model, right? This is your fourth type of model. What was the first type of model?
Build and fix.
Very right. Then the second type was
Waterfall.
waterfall. Third type is
That's right.
Iteration.
Iterative.
iterative enhancement model. Enhancement means whatever the add-ons we are doing, right? Enhancing the features of our product. So that was our enhancement model. Now the fourth is our prototyping model. Do we all understand what is the meaning of the term prototype?
It's actually not completed software. It's like before delivery of software.
Yeah. We
It's
can
kind of
understood it.
blueprint of product.
Yeah, it's
Yeah.
kind of the blueprint of the product. Very
Blueprint.
right. It's absolutely true. Right. We can also imagine that we have the actual car which are available to us, or actual, for example, a motorbike. We also have a miniature motorbike, right? That in the form of a toy form. We all have seen that.
Yes, ma'am.
Yes.
Yes. So that miniature part could be called as a prototype of the actual model, right?
It's like a dummy.
Because yeah, it's like the dummy, because when we are seeing that miniature part of the motorbike, we can actually relate it to the actual motorbike because it looks like that only, right? If we give it to a child also, he will just figure it out that it's a motorbike. How? Because it is actually the appearance of that miniature part is also like the actual part. But do the miniature motorbike have all the functionalities that the actual motorbike has?
No.
No,
Absolutely
right?
no.
No. So that could be considered as the blueprint of the actual motorbike. It also have, so that miniature motorbike will be called as the prototype of the actual bike, right? Similarly, it happens in the case of the prototype, it happens in the case of the software development model, that we develop a miniature, we develop a blueprint, we develop only the outlining of our software, which is called as our prototype model. And then we just kept on improving that blueprint part, or we just kept on improving the outlining part. We just kept on adding the functionalities afterward. First of all, we develop a prototype, we just deliver it to the customer, and we just ask him whether it's fine or not. It's not fine, it needs to have so many another things. We'll just kept on adding all those things, and we'll just finally deliver it to our customer. We'll just read it from here what it says. It says that in this model, a working model of the actual software is developed initially. The prototype is just like a sample software having lesser functional capabilities and low reliability, and it does not undergo through the rigorous testing phase. It is an important line. Whenever you read it now, just focus onto this line also, that the prototype model does not undergo the testing phase. Now, developing a working prototype is the first phase that overcomes the disadvantage of the waterfall model, where the reporting about serious error is possible only after the completion of the software development. Now, if the working prototype is given to the customer for operation, the customer, after its use, gives the feedback. Analyzing the feedback given by the customer, the developer refines, adds the requirement, and prepares the final specification document. Once the prototype becomes operational, the actual product is developed using the normal waterfall model. Now, see, these are all the very important lines. What these lines are saying, a prototype is being developed which is not very reliable, which does not have all the functionalities that are being asked by the customer. Now, this prototype is given to the customer, right? Customer is going to make use of the prototype, and customer is going to give its feedback to the company. Now, the company is going to analyze the feedback. Now, on the basis of that feedback, company is going to add on the functionalities which are being asked by the customer, right? Now, finally, the prototype model or the sample model gets ready, right? And on the basis of the sample model, then all the steps of the waterfall model are being used, and then the final model is being produced, and then it is delivered to the customer. Prototype means before creating the overall product, just develop a sample product, right? That our sample product is this, and on the basis of my sample product, I will just going to develop my actual product, right? We also do it in the drawing also now. Whenever we have to draw something, what we do, we draw that with our dot 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 dot. We draw it with the pencil, and we draw like dot 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 dot. We all do that, right? Now, for example, we are drawing something. In spite of just creating it with the complete lines, what we used to do, we draw it with the dot 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 lines. And when the artwork looks like our own, whatever we wanted to draw, then we just complete all those dots, and we'll just say that yes, this is the product, right? So what that dot 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 wala product, that dot 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 product is our sample product, right? So prototypic model actually works onto the sampling thing. It actually works onto the blueprint. It actually works onto developing a miniature of any of our software product before developing the actual product. Actual product will be developed by following all the phases of the software development lifecycle model, or by following all the phases of the waterfall model. But miniature product is like, it is also being seen into the figure 1.5, that there is a quick plan, there is a quick design, there is a developed prototype which is being delivered to the customer, feedback, and again the quick plan is there, quick design is there, developer prototype is there, customer delivery is there, feedback, and then when everything is being agreed by the customer, then follow the waterfall model and start again from here. So that happens in the case of our prototyping model. These are all the three important features which are present in the prototyping model. What it helps in determining the user requirements more deeply, because there is a feedback process. There could be any number of the times that the user can give its feedback, right? Because what actually is being delivered to the customer is the miniature model. It's the prototype model. He has the right to give its feedback, right? So when more is the feedback, more is the developed model, more is the efficient model that will actually come out as the output. Second is, at the time of the actual product development, the customer feedback is always available, and it does consider any type of the risk at the initial level. Okay, if there is any kind of the risk which can happen, that is also being faced onto the initial levels only. So whenever we are into a hurry, then the prototyping model is being used, because it always have a quick plan and a quick design, and to develop the prototype and to develop to the customer. That happens in the case of the prototyping model. Now the next is our spiral model, right? So what happens in the case of the spiral model? You all have understood about the prototyping model now?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so this is how the spiral model looks like. First of all, we'll see that. Okay, all the phases goes into the in the form of the spiral. It looks like a spiral starting from here. This is the phase. These are all the four phases. It is divided into four squares. Phase 1 phase, 2 phase, 3 phase, and 4 phase, and everything else is going into the spiral phase, spiral manner. That is why it is called as a spiral model. So we'll study about it. What it says that it is considered as this could be considered as the model which combines the strength of the various another model. We are also studying all these models in the hierarchical order also. Look, first of all, which model we have studied? We have studied about this build and fix model. So it came first. Then after that, the waterfall model came. Then after that, the iterative enhancement model came. Then after that, the prototyping model came, and then the spiral model came. So till the development team reaches to the spiral model, we already have the four types of the model available to us, right? And since we have all the four types of the model, we have the advantages and the disadvantages of all the four types of the model available to us. So what we do in the case of the spiral model, we just combine the strength of all the four types of the models together, and we develop a new model which is called as our spiral model, right? We ignore the disadvantages of all the four kinds of the model. What we have focused on, we have focused on to the strength part of the build and fix model, strength part of the waterfall model, strength part of the iterative enhancement model, strength part of our prototyping model. We have taken all the strength together. We have developed a new model which is called as our spiral model. Understood?
Yes.
Okay. Now, what happens? Conventional software development processes do not take uncertainties into account. Now, the most important part of this spiral model is that it focuses on to the unforeseen risk. What are the kinds of the risk that could happen in the development phase of the particular software? So it focuses on to the risk factor also. So that becomes a very important feature of the spiral model. Any another model does not focus as much as the spiral model focuses onto the risk, right? These are all the four types of the primary activities which happens into this model, which you all must remember. First is finalizing the objective, then the analysis of the risk, then the development phase, and then the planning phase, right? So first we are going to see what happens in the finalizing the objective. In this phase, the objectives are set for the particular phase of the project. It means as this project has the four phases, 1, 2, 3, 4, what will be the objective for phase number 1? That is being finalized. Objective for the phase number 2 is also finalized. Objective for the phase number 3 is also finalized, and objective for the phase number 4 is also finalized. So सबसे पहले, first of all, what it do? It finalizes the objectives of all the phases, right? Then the risk analysis. The risks are identified to the extent possible. They are analyzed and necessary steps are taken. After finalizing the objective of all the four phases, then the risk of you can even read it. It is written over here. Just risk analysis, risk analysis, risk analysis. Okay. Second thing is to identify as much risk as much as much risk as possible into the risk analysis phase. Means whatever risk we can thought of is being analyzed into this phase, and necessary steps are taken afterwards. Then we come to the development phase. In the development phase, based on to the risks that are being identified, then an SDLC model is selected and is followed. SDLC model is also a kind of the model that have majorly all the steps which are present onto the waterfall model, right? We are also going to study about this SDLC model later on, fine. After development phase means the development of the spiral model is based onto the SDLC model only, and the extra thing which are being added onto this model is you are finalizing the objective, then the risk analysis, and then the development, and afterwards we are come to the planning phase. What happens in the planning? At this point, the work done till this time is being reviewed. Based on to the review, a decision regarding whether to go through the loop of spiral again or not will be decided. If there is a need to go, then planning is done accordingly. Every time there, just can you see where my arrow is rotating?
Yes, ma'am.
Okay, so it is like this. For example, I'll start from here, right? My cycle or my software development cycle starts from here. I'll go from this phase, I'll go from this phase, I'll go from this phase, and I'll come over here. When I'll come back to this point, then I'll again analyze whether there is a requirement of doing more or not. If there is a requirement of, I'll just see any other risk is there, whether my all the objectives are being achieved or not, whether there is a requirement of more enhancement after reaching to this point. If all the answers are yes, then I'll again go back to the another spiral, which is going to start from here. It is going to come to this point, then this phase is being completed, then phase number 3 is completed, and then another phase is completed. Now I've reached to this point, again I'm going to do the analyzing part. Okay, after analyzing, I feel that there is a requirement of another phase. So I'll start from here, go complete this phase, then this phase, then this phase, and then this phase. And this spiral set of phases kept on repeating until I will reaches to a point when I'll feel that all my objectives have been achieved and there is no requirement of another loop of the spiral. So this happens like this. So very important point, whenever you're going to be like talking about the spiral model, the two important things which you need to talk about is, first is that the strength of all the other models are being taken together and they are being put into the spiral model, right? Second important thing is that the risk analysis part is very much focused into the spiral model. These are the two very important points which needs to be known about the spiral model. Now, another type of the model is our RAD approach. Do we know the full form of RAD?
Rapid application development.
Rapid application development approach, right? Now what happens in all the other model which were present above, we are seeing that there is a lot of amount of time which are being utilized in the development of the software. Now there is a client who comes to us, he has all the objectives very clear, right? He knows what he wants from his software, but the only constraint what he has is that he has a very less amount of the time for the development of the software. He'll just give us, for example, a month. He wants his software to be delivered to him in a month only, right? So what happens in that case? In that case, in spite of using any another model, now what we are going to make use of? We are going to make use of RAD approach. What this RAD approach is? RAD is rapid application development approach. Rapid is, the word rapid means quick, right? Quick application development. We want our software to be developed very quickly, right? So for that, we are going to make use of the RAD approach model. What it says that in this model, the multiple teams are given the task of different components in development. All the objectives, they are being distributed among various teams. Means, for example, 5 objectives are there, right? Objective number 1 will be handled by this team. Objective number 2 by this team, 3 by this team, 4 by this team, 5 by this team, right? So this happens in order to expedite the process, in order to deliver the product on time. So when we divide our work into various teams, what it do? It increases the overall speed of the software development, and it gives a fully functional system within very short amount of the time. So this approach emphasizes the development of the reusable program component. So what we need to remember about the rapid application development approach, we need to remember that two things. First is the requirement of the client. The client requirement is what? He wants his products to be developed very quickly, right? He doesn't have time. So when he doesn't have time, we need to think about the RAD model. Okay, this could be achieved by the RAD model only. So how the RAD model works? The RAD model works by distributing the work into different teams. What this model is going to do? Distribute the work among the people. It is just like the divide and conquer approach. Have you heard about the divide and conquer approach?
Yes, ma'am.
Okay. So this model works onto the divide and conquer approach. Divide the overall development of the software, give it to the various teams. They are going to give their output, combine that output together, a software will be developed and give it to the client. So that happens in the case of the rapid application development approach. Fine.
Yes,
Okay.
ma'am.
Any doubt, any question that you wanted to ask before we start with the capability maturity model?
Excuse me, ma'am. What is the
Anji.
best model in today's software development industries?
Yeah. We could not
Which one
say,
is the best?
yeah, it just depends on to the requirement of the industry. Generally, what the industry do, they follow these steps that are being present into our waterfall model, right? So these are the general set of steps which are being followed by any of the software development company. But it depends on to the requirement of the company. For example, a company receives any order from the client who needs its product to be delivered very quickly. So the company is going to go to that model. It's not any specific set ki if company A is there, it is going to follow the model number 1 only. It's never like that, right? It just depends on to the requirement. It depends on to the needs. It just depends on to which model fulfills the maximum needs of the client. It just depends on to the client requirement also. So all these matches are being done, and the model which excels more, which gets more point, that model is being chosen by the particular company for any particular model. And it's not never like that ki company A is there, it's just going to use a waterfall model. Or it cannot use the iterative enhanced model, or it cannot use the prototyping model. It's never like that. It always depend on to the requirement and various another factor that are being taken into consideration for the development of the model. But in general, basically, even if we are creating a software by making use of the spiral model or by making use of the prototyping model, but still the waterfall model steps are being followed. They are followed either in the starting or either in the end. But these are certain set of steps which are always there, right?
Yes, ma'am. Thank you.
Okay. Then we come on to the next capability maturity model. Now, till now, we have discussed about the software development model, right? Now, in the case of the capability maturity model, we are going to talk about the type of the company, right? There are various maturity levels. They are like 4 in numbers. We have the maturity level 1, maturity level 2, maturity level 3, and the maturity level 4. So what are these maturity level? Maturity level defines the company. That company A is into the level 1, means it is into the initial phase of the development of the development of the software. Now company 2 is into the level 2. So till now we have talked about the various models of the or the set of the steps which needs to be followed by the company for the development of its software, that it has to go through the requirement analysis, is designing and coding and testing and maintenance and feasibility study and so on. Now we are going to talk about the company, that the company lies into which maturity level. Company ka maturity level lies where, onto which standard, right? I'll just read this. The process model are based onto the various software development phases, whereas the capability model have an entirely different basis of development. Means they are based upon the capabilities of the software, and they're also based upon to the capabilities of the company, right? Till now we were discussing onto the capability of the model. Now what happens in the case of the maturity levels, it defines 5 maturity levels which are discussed over here. SAI has laid guidelines regarding the capabilities an organization should have to reach the different levels of process maturity. This is the most important line. SAI is there. What is SAI? SAI is Software Engineering Institute. It has laid various guidelines about what? About the capabilities of an organization. That's what I'm telling you. Enough the capability of the organization or the capability of the software company is going to be considered. So SCI laid the guidelines regarding the capabilities of the organization that should have to reach the different levels of your software process maturity. We'll understand it like this. For example, we have an organization that is of the level 1. That is of the level 1, or the initial level is also called as. Means at this maturity level, the software is developed on ad hoc basis, and no strategic approach is used for its development. The success of the developed software entirely depends upon the skills of the team member. In the maturity level 1 organization, the software process is unpredictable because if the developing team changes, the processes will change. So before going on to these levels, we must understand now we are talking about the capability of the companies, capabilities of the organization. For example, there is an organization which has been set up like an year before, right? Now this organization does not follow any proper set of rules or the set of phases for the development of its software. What it do? It just hires some skilled people together, make a team, and just give the requirement to that particular team. Now it depends on to the team how it is just going to deliver that product, right? It is not any kind of the compulsion for the team to follow any set of rules or to follow any set of the model. So when that kind of the company is there, then that kind of the company falls into the level 1 or the maturity level 1 or the initial maturity level, right? So what happens in this type of the organization? The process of the software process is very unpredictable. So what happens actually, the people are being hired and they're also being fired. If the organization fired the employees in between, then everything is like very haphazard in the case of the initial level companies, right? So why we are talking about the companies, why we are studying about the companies? For example, in any point of the time, for us, we have the requirement of any software development. Now we have to choose from the thousands of companies a single company which is going to develop our software. So what we are going to see? We are going to see the maturity level of that particular organization, that on which maturity level it exists, right? If we are going to, how this is going to help us, if we are going to know about all these maturity levels, then we will be able to understand that this is our requirement, and this requirement can be fulfilled by maturity level 3 company or the maturity level 4 company, or my software is not of very high, does not have very high processing things, so it can also be developed by the initial level maturity company, right? So these maturity levels help us in deciding the organization which is going to develop our software. Understood?
Yes, ma'am.
So initial level we have studied. In the initial level, the organization could be new, the team members are there, there are skilled team members are being hired. There is no particular set of rules and regulations or any kind of the model that is being followed. Means it just follow a very ad hoc process. They have a project to their hand. They just need to develop it by hook or by crook, right? And they are just going to hand it over to the customer. That happens into the maturity level 1 company. Now we come to the maturity level 2 company. We have given the name repeatable organizations to these company. Level 2 means repeatable, right? So the organization, now one thing also, if we are going to talk, if we are going to go to the level 2, then we must understand that the level 2 company are going to satisfy all the requirements which are present onto the level 1. Means level 1 wale jo requirement hai, they are already present into the level 2. Level 3 means level 1 and level 2, all the requirement, all the things are present into the level 3. All the junior level things or the requirements are present into the senior level companies, right? So the senior level 2 company satisfies all the requirements of the level 1 company. So at this level, the basic project management policies and the related procedures are established. The institution achieving this maturity level learn with experience of earlier projects and reutilizes the successful practices in ongoing project. In this maturity level, the manager provides quick solution to the problem encountered in the software development and the corrective action is immediately being taken. The organization of this maturity level have installed the basic management control. So in the case of the level 2, repeatable means, now just imagine there is an organization. That organization has worked on to, for example, 50 projects, right? Means 50 clients have been satisfied that particular organization. Now, for the next project, what this company has the experience, right? This company has the people, this company has the experience of the earlier project. And what they do, they utilize this experience of them to develop their next project. For example, when I was working on to my previous project, I faced this kind of the problem. Or when I was working on to my previous project, I have this code which can be reused into my this present project. So this company works on to the experience which this company has or had after working on to the various projects, right? So this comes on to the level 2 maturity company. And one important thing, what it has the very basic management control, right? Who wants to join now? So that comes to the level 2 company. What happens in the case of the level 3 company? First thing is the organization satisfies all the requirements of the level 2 company. And at this maturity level, the software development processes are very well defined. They are managed, they are documented. Training is given to the staff to gain the required knowledge, and the standard practices are simply tailored to create the new project. Like in each and every level, we are enhancing. Fine. Level 1 company is a very basic level company. What these companies are doing, they are just hiring some skill set of the people and they are just working in an ad hoc manner. That is the initial level company. Level 2 is the repeatable company. Now this company is also not working on to any kind of the processes, but what they have their experience. They have worked on to various projects and they're using that experience for their further development. They have their certain manager. That manager is going to give a quick fix of the any problem. That problem will be solved and the people or the team members are going to work. Now level 3 company is the third level mature company. They are very well defined. They follows a certain set of the process in order to develop their software product, right? Then they have a very well defined, they're managed and the documented set of steps which they follow for the development of their software. And second thing is they just do not hire the skilled people, already skilled people. They also impart or they also give the training to their staff members for the development of the product, right? They hire the people, they give the training and they follow the certain set of process for the development of the software. So this happens in the case of the level 3 company. So we have the initial level, we have the repeatable level, and the third level of the maturity is our defined level. Now moving on to the next level, which is our managed level, right? Managed level, the first line will be the same, which is what? The organization satisfies all the requirements of the level 3. Till here, level 1, level 2, level 3. Whatever was the requirement, all the requirements of the level 3 are being satisfied by the level 4 company. So at this level, quantitative standards are set for the software product and processes. What happens here? The project analysis is done at integrated organizational level and the collective database is created. The performance is measured at the integrated organization level. And the software development is performed with very well-defined instrument. So in the level 4, everything is very, very managed. That is why this level is called as the managed level. And where it is managed onto the organizational level. The project analysis is done onto the organizational level. The database is collected together. And then everything else or the overall performance of the software is being managed and is being measured onto the organizational level. Now it is not working onto the team level, team 1, team 2, team 3, team 4, or onto the basis of the experience. No. Now everything is going to be there measured onto the organization level. Now everything is going to just collect together and it is going to be measured according to the perspective of the organization. So this happens in the case of the level 4 company. So if you're going to go to the level 4 maturity level company, then you have handed your project into the hands of the very good company. You can rely onto that company. They are going to be very much reliable as compared to your level 0, level 1, level 2 companies, right? Now the next level is the last level and they are the most matured level companies or the organizations, and this level is called as our optimizing level. So what happens in the case of the optimizing level? The first line will be the organization is going to satisfy all the requirements of this level. And this is the very last level. So the organization at this maturity level is considered almost perfect. At this level, the entire organization continuously work for the process improvement with the help of the quantitative feedback obtained from the lower level. It works on to preventing the errors. It works on to its weaknesses. It takes the proactive actions. So what happens in the case of the level 5 company or the optimizing company? They are considered as almost perfect companies. Like you can just blindly trust onto these organizations, onto these companies. All the organizations or the entire organizations work for the improvement of the process. For example, if they are even using the waterfall model or if they are using the prototyping model or any of the model, what they're going to see, how this model can be more improved, how can I work more efficiently, what are all the feedbacks of the customer, right? They worked very reliantly onto the feedback given by the customer. They focuses on preventing the errors. They just take the proactive steps in correcting their mistakes. So whatever the best possible could be done by any organization for their product, they're always improving is done by these level 5 or the optimizing company. You must have heard about the various companies. You must have heard about the Nokia in the mobile phone manufacturing companies, right? You must have heard about Samsung's and the Apple. So all these companies worked onto the customer feedback. We all shop from various online sites. Whenever we purchase a product online, we get an email or from that particular company that give us the feedback whether you like that particular product or not. So feedback is very, very important for all these organizations. Feedback is important, and the working on to the feedback of the customer, their overall aim is to satisfy their customer. So the level 5 matured company is the most matured company. They are the most optimizing organizations, and they are the best organizations for your product to be developed. They make use of the bestest of the technologies or the new technologies. Their cost benefit analysis is also very much clear. So whenever we as a customer or we as a client have to decide about the organization by which we want our product to be delivered or we want our product to be manufactured, then we can take into consideration about this capability maturity model. We can check on which level the company lies, and then according to our requirement we can go and choose our particular company. In this particular topic, you have to just remember about this, ki who has developed this capability maturity model and what are all the 4 maturity models and what these models are saying and what are the differences among the organizations which are lying onto the different or the various maturity level models. Understood?
Yes, ma'am.
Okay, any problem?
No, ma'am.
Okay, beta. Then we are going to talk about
Yes, ma'am.
just this.
No problem.
वो- हाँ हाँ बताइए. Okay. Then we are going to study about this software process technology. Now, what is the software process technology? You must have heard, I've used this term earlier in today's lecture only, software development lifecycle. Have you heard? SDLC, I've said it, software development lifecycle. This is very, very important. It means the entire software engineering comes into this software development lifecycle, right? As the name indicates, this is the kind of the cycle that is being followed in the development cycle of any of the software. So that comes under your software development life cycle. What it says that the various steps called as the phases which are adopted in the development of this process are collectively termed as the software. We all know what is software, we all know what is development, we all know what is life cycle, right? There is a cycle, there are a set of phases, there are a set of rules, there are a set of steps that needs to be followed, that needs to be presented in the development of any of the software. So we are going to study about all these phases. Basically, generally, these are all the phases. What? Requirement analysis, designing is there, coding is there, software testing is there, and maintenance is there. All these steps have also come into our waterfall model. You remember it?
Yes, ma'am.
Yes, ma'am. Yes.
Na? We are studying it from starting only. So this is also called as the software development lifecycle process, SDLC process. In the short form, we say it like that, SDLC, SDLC. So these are all the phases of the SDLC. We have got the requirement analysis, designing, coding, software testing, and maintenance. Before doing that, we are just reaching on to the completion of the time, and I'll just take a snapshot. If you all can come, you all can switch on your camera, so you all can do that. Can you switch on your camera? Okay. I'll just take a snapshot. Fine. Thank you. Just a second. Okay, now we are going to talk about the requirement analysis phase. So requirement analysis is doing what? It is just explaining the what of the system. What of the system means what the software is all about. That comes under the requirement analysis phase. Requirement means the needs of the customer. Analysis means when we are just analyzing them, we are just focusing what are all the requirements that are being asked by the customer. We are just paying attention on to those requirements. So what we say that what of a system is being considered into the requirement analysis phase. The objectives, I've even explained it earlier also. The objectives which are to be achieved in the software process development are the requirements, the objectives, the needs, what the customer wants from your product. They are being achieved. How they're going to be achieved is going to be seen in any other phase. But what the requirements are, they are being considered into the requirement analysis phase. What else happens into this phase? you just do not hear the requirement from the customer, that you talk to the customer and you have just remember them and they are being taken. No, it just do not happen like that. You just take the requirement, you just note them down, and there is a proper document that is being framed which just talked about the requirement of your customer. And what that document is called, that document is called as the software requirement specification. As the name suggests, what this document is going to contain, this document is going to contain the specifications of all the requirements that a particular client has. So the output of the requirement analysis phase is what? The SRS document. Just remember it. You can be asked from anybody that what is the output of the requirement analysis phase. So the output of the requirement analysis phase is your SRS. We say it as the SRS. What is SRS? SRS is the software requirement specification. How we are going to define the SRS? It is the document written into the natural language which has all the requirements specified by the customer noted down in that particular document. Everything is noted down, jotted down. All the requirements told by the customer are being just put it into that document, and that document is named as the software requirement specification document, right? It can also be defined as the process of studying the user needs to arrive at a definition of a system hardware in the system requirements, software requirements, and the process of studying and refining the system hardware or the software requirements. So we have studied about this requirement analysis. We have understood output is your SRS. We cannot cram it like line by line. We just have to understand the thing. So what we understood by the requirement analysis, we have understood that requirement describe the what of a system. What is there into the system, what is going to come to the system, what are all the objectives that needs to be achieved by the system. They are just noted down into a document. That document is called as your SRS document, which is also an output of the requirement analysis phase. Then we are going to come to the design phase. I think we will not be able to complete it today. We can take it in our next class. We'll start from the SDLC only. The time is just ticking.
Yes,
Fine?
yes, ma'am. I think
Okay,
it is enough.
it's
Yes,
actually
okay.
a long. Okay, fine. Any another problem?
Thank you, ma'am.
Okay, beta. Fine. We'll meet in
No
the next
problem, ma'am.
class. Okay, beta. Okay.
Thank you, ma'am.
Have a good day. Okay, beta.
Same.
Thank you, ma'am. Have a good day.
Okay. Bye, madam.
Bye. Have a good day.
Thank you.
Bye.
Thank you.
Okay, beta. Okay.
Hello. Mom, can you hear?
Ma'am has gone. Safir John ma'am has left.
دانشیار صاحب خوب هستین؟ صحت
لا
شما
غیر
خوب
از
است؟
شکر فضل خدا شما خوب هستین دوستان؟
سلامت باشین، بخیر باشین. ببخشین امی درسای قبلی ده اینا اپلود کرده بودن ریکاردایشه؟
ریکاردای درسای فکر کنم که قبل از ما شما هم کدام سمستر دیگه درس دادن اپلود کردن در موقع.
نه از امی درسای خود ما را مثل که از اون دکتر چی نام داشت و کسی دو سه درس دیگر الگوریتم را که درس داد اونا اپلود کردن.
ریکارد میکنن. نمیفهم که ریکارد خود میکنن هر روز نه؟ ریکارد میکنن و چک نکردیم که اینا
اپلود نکردم. من چک کردم. اپلود نکردم.
من چک میکنم.
نه اپلود نکردم. اینجا دوباره ایش کردم.
نه میره
نکرده باشم در گروه برنامه
از او
که
پیچیده هم هست. از او که از یوتیوب به بالی خواهده اگه چیز پیدا کنه.
خب بر صورت
خیر هم
خوب گپ از دوستا که می هر بار که مثلا نمی اینا درس لکچر میتن ما بفهمیم که اینا کدام چپتر درس میتن. و راستی و آدم قبلی من نمیفهمید کدام چپتر بخیر من کانفیوز کننده بود. خوب بود درس امروزی ما چون آدم خوب درس هم دادی استاد ما.
از این
غیر از الگوریتم دیگهش خوب است.
و الگوریتم دیده خداوند اگه نه باید استاد الگوریتم باید تکلا باشه که تو بر تو الگوریتم یک بار
باید تشریح کنه اون استاد یک ساعت بهش نکرد میزنه یک گپ بزنه
با سخت‌ترین هم همی ریاضی و الگوریتم
یک فیدبک میتیم که بپره دیگه دفعه بعد
سلامت باشین. تشکر دوستا.
باشه.